Robot Talk is the podcast that sits down with roboticists from around the world and asks them the questions you always wanted answered. Like, can that robot build me a house? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and in today's episode, we're exploring the latest developments in construction robotics. Specifically, how automation and localized fabrication can help ease the housing shortage and address the climate crisis. Before that, don't forget to rate this episode and leave a review, if that's something you can do on the platform you're listening on. Another way to support the podcast is to share new episodes on social media or tell your friends about it. It really helps me reach more listeners, so thanks in advance. So, without further ado, let's get on with this week's interview. I recently had a great chat with Vikas Enti from Reframe Systems about using robotics and automation to build climate-resilient, high-performance homes. This week, I'm talking to Vikas Enti, co-founder and CEO of Reframe Systems, a construction company using robotic microfactories to build climate-resilient, high-performance homes. Hi Vikas, great to have you on the podcast.
Hi Claire, thank you so much for having me.
So you co-founded Reframe Systems in 2021 with the goal of addressing both the housing and climate crises using robotics and automation. So first of all, can you tell us a little bit about the company?
Absolutely. So we're actually founded in 2022.
My mistake.
I think our pitch book entry is a little outdated there. But yeah, Reframe, like our mission is to make housing resilient and abundant. We're working on two of the hardest challenges of our generation. That's how do we mitigate the housing crisis and the climate crisis.
Yeah.
And we believe technology is the right solve here, and how we can work in an industry that's been highly fragmented and very stagnant in its productivity for a few hundred years. We see a pathway here to truly industrialize it, but by doing it in a way that avoids the pitfalls of a lot of prior approaches on just trying to bring housing into factory manufacturing mode, where people have mischaracterized this as a mass production problem. For the US, given the size of the country, the unique site conditions, climate codes, and we have a very arbitrary zoning jurisdictions, about 30,000 jurisdictions for zoning.
Wow.
It's incredibly hard to design one product that can be mass-produced at scale. We believe this is a mass customization problem, where we should be able to have a high-mix manufacturing system that our software can design, right, the homes that are relevant for the lot that's unique, but have a manufacturing system that can then take those instructions and produce, right, any variability and combination that we need of a home and produce that for zero marginal cost. So like that's the end state we're trying to get to. But we started recognizing this is a mass customization problem. And what we've done is develop a design and manufacturing system that leverages advanced software and robotics that allows us to accomplish that goal in a very small footprint. And we're using that system to produce homes that are incredibly resilient. So they're all zero energy ready by default, can be upgraded to be truly net zero. But they're also designed to exceed your snow loads and wind loads. So the structures actually withstand heavier load conditions and what codes require. And more recently for California, we've been focused on designing for wildfire resilience. So our homes actually for California today have additional fire rating systems involved to get them to withstand any type of ember ingestion from the outside or having any combustible surfaces. And we're trying to do all of this, but by leveraging technology, we're able to make sure that we're not passing on a green premium to our customers.
Okay.
So we're driving both great speed savings. We reduce schedule almost by 3 times for a lot of the structures. So we've been able to go right from foundation to completion in as little as 150 days for a 3-story apartment complex. And the goal is to get to 45 days for a lot of our smaller single-family homes. And in terms of cost, we're very focused on what we call the urban infill missing middle market, which is extremely mispriced for construction. And today we're almost 20% lower in costs in these markets.
Impressive. Yeah, I mean, I think it's brilliant that you're building homes that are both, hopefully not contributing more to the climate crisis, but also are equipped to deal with the future climate change that they will inevitably have to face. Can you talk me through the process? So, you've got a plot of land that you want to build a home on. Talk me through what that process looks like from start to finish.
Absolutely. So we work with developers as our primary customer. So developers are either coming to us where they already have a parcel of land and they sort of give us those details. Our team's running. We've been developing a bunch of tools to quickly analyze that parcel of land to understand everything from site dimensions to topography to what the zoning constraints are, to understand what types of products that we already have in our portfolio would fit that parcel. And does that meet the developer's programmatic needs? And if the developer says, hey, I need to add 12 units as my goal to build on this land, and we figure out how to add those 12 units of housing. Do we fit 12 single-family homes? Do we add triple deckers? Do we actually build one simple apartment building that has all 12 units? So our software and workflows are sort of driving through that exercise with one of our pre-development leaders. We run that feasibility. We're also checking for logistics on, can we bring a crane to that site? Can a truck with our modules show up? What's the largest dimension of a module that the project can support? And we use all of that to then establish, are we a good partner to be able to deliver products that meet that site in our current roadmap? We're able to provide high-level pricing pretty quickly. And our pricing has much more rigor to it because we already have a good sense for what the bill of materials are for everything that's above ground. So it's not just a finger in the air, everything it's going to cost us. We have a lot more data to back it up. And we have some uncertainties around site work, right? Anything that's horizontal in the dirt, that will have to go and do additional surveys. So there we hold an allowance. We're able to provide a fairly good estimate to our customers who then are either happy with that estimate, they're able to proceed with us. And once they proceed, we very quickly go from, if it's already a pre-designed product, then our software is able to take over with an architect in the loop. We're able to quickly make the necessary customizations to make that product compatible. And our whole software workflow, we call this pixels to parts, runs through that system, delivers a high fidelity, engineering ready, manufacturing ready CAD model, where we're modeling every single wire, pipe, duct, in addition to the structure. And then it automatically orchestrates information from that model into instructions that go to a bunch of different systems. So we go into our automated saws and routers. So they're cutting all of our material. So all the instructions go to those systems directly from the model, along with print instructions. Then we have instructions that go to our robot on how to frame these components. But then we also have the biggest place we're adding value today is having the same instructions also go to iPads through an app that we built called Sidekick that gives all the instructions required to assemble these structures to our build team. And we've simplified the process significantly where an apprentice, sometimes when high school co-ops who are working with us, are able to do some really complex plumbing, electrical, HVAC work, depending on the instructions they're shown. But the beauty of the system is we could have triggered that work to go build these 12 units. And now the next order that drops in might be for a bungalow that has to go to California as part of the wildfire rebuild. Same process goes through, the orders drop into the factory. As far as the build team is concerned, they're following instructions on their iPads. So it doesn't matter if they are doing the plumbing for a shower wall that's going to California or it's going to be in the local market the factory's in. They're just following the instructions on their screen. All the pre-kitted components come to them to a point that they're not having to reconcile the differences between project types and where stuff's going, which is where we start getting a lot of advantages in how we can do hot mix manufacturing. So the robots are easy to talk about because they're the most visual part of our system. But a lot of our cutting edge progress that's already delivering value today is coming from this entire software operating system we built called Pixels to Parts. That actually unlocks a lot of IP, but it also enables the robot to do what it does well. And this allowed us to create a roadmap where we see a path to automate about 65% of all the tasks by 2030 as we go through our robotics roadmap.
Okay. So, I mean, that leads really neatly onto the next thing I wanted to ask you about, which was when you're talking about building a home, which of the tasks of that big project are really well suited for robots to take over? And which tasks do you think are, at least for the foreseeable future, better left to skilled humans?
Yeah, so we have a philosophy here. Like, our goal is to not solve for 100% automation. And we've been through that rodeo and exercise before from our prior lives at Amazon Robotics to realize that it's a very unbounded problem and just doesn't deliver the right decisions. We instead see this as, call it a human-robot collaborative system where we can drive value and have each system do what it's really good at. And to us, I mean, our goal, the whole goal of building a company is we're attracting people that are attracted to the mission and are enjoying the work they do. So part of our thesis has been there's sufficient types of work in the manufacturing and construction process that are highly repetitive, but also not visible to the end user. So a lot of things that go inside a wall.
Yeah.
That's been a good candidate where we said, these are things that our builders don't get to show off once the walls are closed to be able to say, I did that.
Yeah.
So that to me seems like a good place where we should be able to continue focusing automation on, and then upskill our build team to focus on the finishing tasks, right? So getting your finished trims done, your cabinetry done, right? There's a bunch of things that they get to show off and say, hey, I put this together. So we've sort of seen a simple demarcation. So today we've been very focused on automating a lot of the steps in rough carpentry. So everything from cutting our material all the way through assembling them into walls or ceiling panels. And that's where the robot comes in. And now we have a roadmap to do the next task called sheathing. Is how do we now autonomously apply gypsum board or OSB or plywood, all the sheet goods that go on top of a frame structure. Then we'll get to insulation, and we'll eventually see a path where we can also install electrical outlets and conduits, not the wires themselves, but at least getting all the prep work done. With the goal that we can start fully enclosing these panels robotically. And this allows us to get a pretty high coverage of work that then still presents the work surfaces that our builders can work on to then do the finishing tasks and get the final assemblies together. And there are certain tasks that we're yet to build conviction on how automatable they are. Things like plumbing, dealing with very pliable, flexible pipes, we think is a pretty unconstrained problem today. And our build team is really good at doing it. So those places we've said the goal is not automation, but augmentation. How do we pre-cut the components, present enough instructions that is very intuitive and how it actually comes together? So we'll continue playing this algorithm of design to simplify, right? So eliminate as many components or subsystems as necessary so we have a simpler system to start with. Augment the builders to perform tasks efficiently, and then automate the dull, repetitive tasks, and sort of keep iterating on this algorithm so that we can continue driving the overall cost of our housing system down and make the process incredibly fast to build.
I get a little hint in your answer there that it's not solely about what humans or robots are good at, but there's a little hint of what humans find satisfying or enjoyable to do. I guess it's really important that the humans in this collaboration actually like their jobs.
Yeah, I mean, it's really important to my co-founders and I that we're building a company where people are enjoying the work while creating massive impact to society and to our planet. And that has been a key guiding principle for why we started the business and how we drive value and derive joy out of the process.
Yeah.
And we want to be able to make sure everyone who's here, right, be it if they're working on the R&D team or working in our factories or in the field, that they have a process where we've been able to constantly eliminate the frustrations that have existed in the construction process, the manufacturing process, and just make it an enjoyable place where we're able to pay really healthy wages, but also take a lot of the repetitiveness out of the job description.
Brilliant. So we had an audience question from Hassan on Blue Sky who said, how autonomous are the robots that you deploy? And maybe if you can put a percentage on that, if that's possible.
Definitely. So our approach for our robotic panelization today, it's an industrial robotic arm where we have layered in our vision system and vision algorithms. And we have our own end-of-arm tooling and magnetic fixturing and a bunch of other subsystems that people can look at videos on our website to see more. The robot's making decisions on the fly. Every time we present it a cart full of studs that it has to then frame into a wall, right? It's scanning the first set of barcodes it sees to figure out what panel it's actually building. And then it's making on-the-fly decisions for how do I pick up the stud, right? Find its midpoint. How do I make sure that the stud doesn't collide with anything around it? So it's actually doing dynamic motion planning. And then once it places the stud in the right place, it's also fixing magnets to make sure the whole structure is compliant. So it's making a lot of decisions on the fly to get to that point. The easier way to have done this, but not a robust way to do this, would have been just hard code pick and place motions, right? Which is what happens in traditional manufacturing where robotic arms are just executing pre-programmed maneuvers to weld stuff, etc. To us, that wouldn't have worked in our system because we're building a very high mix manufacturing system where we should be able to frame any type of panel, right? Panels that might have windows in them, panels that might have doors in them. Eventually, we want to be able to do roof trusses and build panels that might have arches in them. So we built a highly flexible system. And to make sure we can deal with that flexibility, it's important that the robot's able to make decisions on the fly, be able to react to changing inputs as to provide the outputs that are required. So from that standpoint, you could argue that the robot's autonomous in executing its set of actions. And it's autonomous for the set of actions today, which go from placing studs to nailing studs. So we actually have a fully frame wall panel. And where we need to get additional tasks that are fully autonomous are now how do we then get sheathing to happen? How do we then get the robot to actually able to unload the panel and place that onto a panel cart so the panel can move on to the next station? Those tasks today have human in the loop, and we have our technicians ensuring that they can actually unload the panels and then sort of get that moving. If I zoom out to our 2030 vision, right, in addition to the robotic arms that are going to continue having, I think we have another 6 different tools that we have to develop over time to get full coverage. We're also looking to integrate AMRs, so autonomous mobile robots, that allow us to move these panel carts and also move the panels from one robotic work cell to the other. So one robotic work cell might frame and sheath it, panel moves to the next work cell where we can insulate it, add the electrical conduits outlets, apply the next layer of sheathing. So we see this dynamic pathway where we're going to have there teams of robots working together alongside people. So I'm sorry, this is a longer answer than that simple question. But it's a lot of context that it's unlike the way you would think about, right, is a car autonomous? Is it at level 1 or level 5? There's a lot more nuance in our system. But a lot of the work that the robots are doing, they're making decisions on the fly to ensure safe operation, but also high quality assembly.
Yeah. So one thing that we haven't really talked about yet is the kind of micro factories approach. Do you want to talk a little bit about that?
Absolutely. It sort of goes back to the analogy I was driving on mass production versus mass customization. When you're building a low mix manufacturing system and you have a single type of product, the most efficient thing you can do is build mega or giga factories that allow you to consolidate all operations. You have a final finished assembly, and then you basically figure out to optimize the logistics and supply chain to deliver those assemblies. That model doesn't work for housing production, especially in the US, because of the mass customization challenge. It's very hard to keep such a large factory fully utilized. So the failure mode we've seen is you end up with factories where you're spending $30 to $100 million to outfit them. And unless they have a really robust pipeline, they're at risk of becoming a not going concern very quickly. So we designed for the counterfactual, which was recognizing as a mass customization problem. The question we asked ourselves is, what does it look like to design a manufacturing system that can break even at less than 30% utilization and take a wide range of inputs? That allowed us to define requirements where we said, our factory should be 50,000 square feet or smaller, so 5,000 square meters or smaller. So we can actually deploy them and place them within an hour or two of major metropolitan markets. So we can also be close to customers. So that way, we don't have to have every factory built for every jurisdiction. We can actually have factories specialized in the jurisdictions they're part of, simplify supply chain. And we also design constraints where we can start a factory for as little as $1 million in capital equipment. And the nominal size we've put together for a factory that can produce 500,000 square feet of product a year, about 250 single family homes, is about $5 million of equipment.
Wow.
So we sort of work from those constraints. And we've devised the system. We're actually well within those constraints on the capital cost standpoint. We're giving ourselves a little bit more room on the size, because if we undersize a facility, it's very hard to add more space. We rather make sure we have some buffer there. And we've also taken a goal on how do you launch these factories in about 100 days, right? From occupying a building to being able to produce the first article. And that speed, we believe, will become the ultimate unlock, because what it does is the way we would enter new markets is not have to pick a market, launch the factory, and then hope we can land customers. We can actually sign customer deals and know that we can react to that deal in 100 days, right? To be able to manifest the capacity. So this really allows us to flip the cash dynamics for a manufacturing heavy business. And so collectively, think of it as a highly software enabled advanced factory that can do high mix manufacturing in a very small footprint for very low fixed costs. And the goal is, how do you make the factories just as resilient as our homes are, so they can deal with changing requirements and any changing market cycles.
And I very much feel like this localized production system is a part of our climate adaptation and climate resilience, right? Reducing the transport that you have to do and doing things small scale and local rather than big scale, like you said.
Definitely.
So obviously, as I mentioned, a key part of Reframe Systems' mission is creating net zero homes and also reducing the carbon footprint of constructing those homes. So can you talk a little bit about how robotics improves efficiency in construction?
Yeah, so there's several decisions that go into getting to a high performance home, right? So one piece of it is, what is the overall recipe for the building envelope? How are we getting the right amount of insulation and making sure that the envelope is airtight? What we're finding is that factory build precision allows us to get to much more airtight structures a lot more easily than on-site construction. And in our factories, combining with the fact that every piece of material is cut with automated systems and assembled with robots with very high precision, we end up with building blocks that allow us to achieve airtightness a lot more easily than if we were to do the whole process manually. So that combination of having the right envelope assembly design with the airtightness and precision is allowing to make sure that our structures start off with a pretty huge advantage in how we get to achieve our carbon goals on the energy side. The other choices we made, and this comes from our design system, is how do we also specify materials that have lower embodied carbon. So all of our insulation is a wood fiber material that is carbon negative, which really helps with our embodied carbon profile. We've made some choices as relates to our use of concrete. So our foundation systems are hybrid systems with helical piles and some precast concrete grade beams. So we use almost 70% less concrete than a typical foundation system. And we've also made other choices on materials that sometimes are more expensive, but as we look at our overall thesis, that we can keep driving the effective cost of these homes down because we're applying efficiencies on reducing material waste, but also reducing labor, allows us to pinpoint locations that absorb higher material costs because they're actually better for the environment. So an example is flooring. For the segment of the market we're building homes for, vinyl flooring is very common. We've chosen to go to an MDF wood composite, which is a superior material, superior user experience. Costs a little bit more, but it's much better for the planet. But it's a decision that we know we can sort of absorb that cost increase because of efficiencies we're driving elsewhere. So this is how I see it, is that it's a systems problem, right? It's at the end of the day, we're not a robotics company. We're really good at developing robotic solutions, but we believe we're a systems company that's going to make decisions across the entire stack to make sure our homes are high quality, safe, and resilient, but also that our factories are extremely robust to be able to produce these homes.
Yeah. So, I was really excited to get to interview you, in part because I've been really wanting to interview more people who work in the area of construction robotics, but they are hard to find. And I think part of the reason for that is that the construction industry has been quite slow to adopt robotics and automation. Why do you think that is?
Historically, there's a slightly different challenge. It goes back to a point I made earlier about fragmentation. And this data is relevant for the US market, but I think some of this applies to other markets too. The number of construction companies that we have versus how much market share they represent is vastly skewed. Like the largest set of construction companies together might still represent less than 1 or 2% of market share on the design build side. Okay. When you look at the largest home builders, it's very top heavy, where the top 10 home builders might represent 20 to 30% of all homes built, but there's still like 3,000 other home builders or more that are doing the rest. So what ends up happening here is a situation where no player is large enough to make sizable R&D investments to be able to change the process. So the industry has sort of gotten this local minima where the only way to be profitable and successful in the business related to construction or development is to own as little as possible of the pie, so you have no fixed costs and you're effectively leveraging subcontractors. So construction has become a very large coordination problem. And all the innovation in the construction industry has been about, hey, better planning tools that allow you to really deal with the messiness of the coordination challenge. So as a consequence of that, there are very few players who are well capitalized to then say, okay, we're going to go and run experiments with robotic companies that can do stuff. Right? And we've seen some good success with companies that are doing layout printing. Right? They're effectively mobile inkjet printers that will drive around floors and mark stuff. And I think they've seen really good success. But they're solving a problem that didn't have a good paradigm on the manual side. So they actually presented a better way to do things. And then we've seen companies trying to do things like drywall finishing, et cetera, or even trying to hang curtain walls. So companies are basically saying, we'll bring a robot into the physical construction site and find ways to perform repetitive tasks more efficiently, or take a dangerous task and automate it. And I think we'll see, as we sort of overlay the challenge with labor availability, and we have a thesis on that, we actually believe that we don't have a real labor shortage. We have an efficiency problem, which makes us underutilize the labor that's available. But regardless, it presents itself as a lack of availability of labor. And that's where we're going to see a lot more interest for companies trying to go after automation. But our thesis has been, and a lot of this is earned experience from our days at Amazon and Kiva, it's very tempting to automate an existing process and like as you see the process and say, hey, you see a person doing these 5 tasks and we automate the tasks there.
Yeah.
What we found is you don't get a lot of leverage with that decision. Where you get a lot more leverage to be able to take a step back and say, like, the outcome is to get a home built. If you could automate processes, what is the most efficient structure or environment to get leverage from automation to drive that? And we concluded the factory was a better way to do it because it actually allowed us to control a lot of the parameters, allows us to also bend gravity, right? Like we get to build our walls and ceilings before we build the floor. Yeah. So said differently, it really allows you to change the order of operations that would constrain you on the field to do it in a way that you actually maximize the amount of opportunities for automation, but also get more value for automation that gets deployed. So we made a bet that the factory build thesis is the superior one in the long run. It's not for every type of project, but it allows us to at least solve the problems we're looking at in terms of building more missing middle housing. And we see this as a good platform where we get to add a lot more robotics coverage. But across the industry, I mean, we're talking to several other startups in construction and robotics, and we expect to see an uptick there as builders and general contractors are going to look for more efficiencies in their operations. And I think there's room for both robotics in the field and in factories.
Yeah, I mean, it's such a good point about not trying to make automation do it the way a human would. Like, dishwashers are brilliant, but it's not a set of robotic arms that like washes the dishes for you. Right. Although that would be very amusing. So, I think too many robotics companies are just focused on exactly mimicking the human way of doing things without kind of thinking outside the box.
Definitely. So I think that's the place where, right, for anyone who's listening and considering starting a robotics company in this space or just a robotics company in general, I highly recommend you take a step back and sort of challenge the assumptions, focus on the problem that needs to be solved and what the outcome is, and then figure out the most efficient way to get to that outcome. I think you'll find that the solution ends up being vastly superior over time.
Yeah, absolutely. Vikas, it's been fun chatting to you today. I've been speaking to Vikas Enti from Reframe Systems. Thank you.
Thanks, Claire.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. And check out @Robot Talk Pod on social media to see a photo of one of Reframe's industrial robotic fabrication systems. Next week, I'll be speaking to Simona Aracri from the National Research Council of Italy about robots to study the ocean. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk Season 6 is sponsored by the Hamlin Centre, Imperial College London.